Hello. For this session, we are going to investigate factoring quadratics with the quadratic formula. Now, the method that we are going to use works for any quadratic expression. However, in this video, we're going to focus on quadratic trinomials that are factorable over the set of rational numbers. Suppose we have this particular quadratic expression, x squared minus 70x minus 29,400. To use this particular method, we would first set the expression equal to 0. Then we would use the quadratic formula to solve that equation. The solutions that we get are x is equal to 210 or x is equal to negative 140. Next, we would take these solutions and use them to determine what the factors are for the original expression. And to do so, we would rewrite both of these equations so that 0 is on the right side. So we get x minus 210 is equal to 0, or x plus 140 is equal to 0. Then we would put these expressions that are on the left sides of the equations together to form our factored expression. So we have x minus 210 and x plus 140 as the factors. And it is strongly advised to check this with the distributive property, which is also called the FOIL method, to confirm that we have the correct factors. Now let's check out another example. Suppose we have 4x squared plus 159x plus 1,332. If we use the same method for this one, we would set the expression equal to 0. Then we would use the quadratic formula to find the solutions to the equation. So we get x is equal to negative 111 over 4, or x is equal to negative 12. Now let's keep in mind that the first solution that is written here is a fraction. And if we want to convert this particular solution to a factor of the original expression, it may be helpful to multiply both sides of the equation by the denominator first. So we get 4x is equal to negative 111. Then we can add 111 to both sides. Also, let's add 12 to both sides of the other equation. So we get 4x plus 111 is equal to 0, or x plus 12 is equal to 0. And then we can put the expressions that are on the left sides of the equations together to form our factors. So we have 4x plus 111 and x plus 12 as the factors. And of course, we can check this by using the distributive property, which is also referred to as the FOIL method. All right, now let's consider this particular example. For this one, we have 2x squared minus 76x minus 528. Now, this particular expression is factorable, but when we use our particular method with the quadratic formula, we will end up with an expression that will need to be changed a little so that we will get back to the original expression when we multiply the factors together. What we need to keep in mind here is that we have a 2 as the leading coefficient, and that will become important later on. So first, let's set this expression equal to 0. Let us solve the equation using the quadratic formula. So we get x is equal to 44, or x is equal to negative 6. We will rewrite both of these equations so that 0 is on the right side. Then we would put them together to form our factored expression. Now, for this particular expression, if we do use the FOIL method, we see that the leading coefficient is 2 in the original expression. But if we multiply x times x, we get a coefficient of 1 for the x squared. Now, to compensate for this, we would take this leading coefficient and just put it in front of this factored form. So we have 2 times x minus 44 times x plus 6. So therefore, when we multiply all these factors together, we will get back to the original expression. And therefore, we are able to confirm that we have the correct factors. Now, in some cases, the number that we need to put in front of the factors to get back to the original expression is not the same as the leading coefficient of the original expression. In those cases, we would need to find the appropriate number that we would multiply to the resulting factors to make sure that we get back to the original expression. Now, for this particular example, feel free to pause the video and try it on your own. All right, so let's check this. So for this particular expression, we would set the expression equal to 0. Then we would solve the equation. We get our two solutions. And let's keep in mind that both solutions are fractions. So we're going to multiply both sides by the denominator of the fraction for both equations. And then we can, from there, set the equations to have 0 on one side. And then from here, we can put our expressions together to form the final factored expression. And of course, we can check this with the distributive property.